Alright, so today we're going to be talking about extreme values of a function. We're going to be talking about extrema, aka maximums and minimums. We need to be able to distinguish between absolute extremum and relative extrema, and how to locate them. And we have used our calculator in the past to calculate a maximum and minimum value. This course, however, in calculus, we have to be able to reason to find maximum and minimums. Unfortunately, calculus is all about that reasoning and explaining yourself and all of that kind of good stuff. Alright. The definition of absolute extrema is just the absolute biggest or the absolute smallest y value on the interval. So let f be defined on the interval I containing c. So f of c is just a fancy way of saying, hey, the y value. Minimum of f on the interval I if f of c is less than or equal to f of x for all x on I. Similarly, f of c is the maximum of f on the interval if f of c is greater than f of x for all x in the interval of I. So what does this mean for us? Well, for us it means that we get a new theorem, which is actually pretty important. We will need to know the difference between some of these theorems here in a little bit. For right now, let's just talk about this thing called the extreme value theorem, which basically says if f is continuous on a closed interval of a to b, then f has both a minimum and a maximum on that interval. So, example 1, we're just going to be looking at this fun function, which is f of x is equal to the square root of 4 minus the quantity of x plus 2, quantity squared, all underneath that square root, is shown below. Yay, semicircles. We need to find the absolute extrema of the function on each of the given intervals if no maximums or minimums exist, which part of the extreme value theorem hypothesis is not satisfied. So in part A, we're just looking on the closed interval of -4 to 0. So -4 to 0 is this entire actual graph because that is spanning all of their x values on that particular graph, so that part we're okay with. So the next part that we need to make sure is saying, okay, well, is this continuous? Can I draw it without picking up my pencil? Yes, I can. So yes, it's continuous. And is it on a closed interval? Looking to see, hey, I've got brackets on the interval, so yes, it's a closed interval. Alright, those are the only two ideas that I need in order to say, hey, I have to actually have this extreme value theorem, is I need it to be continuous and I need it to have a closed interval. If those two things are true, then I'm guaranteed to have a maximum or a minimum on that interval. Well, technically I'm guaranteed to have both. Alright, since those two things are satisfied, I can just look at this graph and I see, hey, I've got a maximum at +2. And I've got a minimum, well, actually I've got two minimums, at 0. Because remember, your maximum values and your minimum values come from your y values, not your x values. Alright, so again, because it's continuous and it's on a closed interval, that extreme value theorem works. What happens if I don't have a closed interval? Well, that's what we're going to be looking at on B. So on B, I've got my interval from -2 to 0. Alright, which is just this piece of graph. Oops, I need to probably pick a different color. So from -2 to 0 is just going to be this piece of graph here. Alright, so is it continuous? Yeah, I can draw that without picking up my pencil if I really wanted to. Is it on a closed interval? No. So all of that means is that that extreme value theorem doesn't really apply because, again, we don't have the closed interval in order to say that this extreme value theorem applies. So does everything, fall to bits and shambles? No, it really doesn't. Alright, we can still find some of these things. Looking at that, we still have a max at 2 on that interval because there's still a pretty solid point up there. But my minimum, well, my minimum's normally at 0, but right now I've got this open circle sitting here, so I can get really, really close to 0, but it's not actually at 0. Since I can't really determine how many zeros go in front of, a 1, I can't say that I necessarily have a minimum at a certain point. So in this particular case, there would be no minimum. Alright. And finally, this last one, I'm going to go ahead and I'm going to look at from -4 to -2. Alright. So, is it continuous on that interval? Yeah, it is. I could draw that without picking up my pencil. Is it a closed interval? Absolutely not. It is not a closed interval whatsoever. That giveaway is that it's in parentheses, not brackets. And also, now that I've redrawn that part of the graph, there's also 2 gaping holes in that graph. Alright, so in this case, do I have a maximum? Well, no, I would not, because there's a gaping hole at what used to be my maximum. I know that gets really, really close to 2, but I can't say how many 9s are after the 1 point blah. And then my minimum, there's also usually at 0, but unfortunately I can't say how many zeros go in front of the 1, so it'd be 0.00000001 maybe, or more zeros. Who knows? So because I can't determine that, I also have to say that there's no minimums on this one. Again, in order for that extreme value theorem to apply, you have to have a continuous and closed interval. That is the only way to guarantee that you have a maximum and a minimum that you can find.